Hello, thank you for watching this video. So on this video I'll be doing question 9 of November 2020 question paper, mathematics paper 1. So I'll read the statement of question 9 and then proceed to read the questions that follow. So question 9. A closed rectangular box has to be constructed as follows. Dimensions: length, breadth and height. So a closed rectangular box has to be constructed as follows. This box must have the dimensions, the length, the width and the height. Second point, the length of the base has to be 3 times the width. Let me read this again. The length L of the base has to be 3 times its width, and the volume of this box have to be 5 square meters. Cubic meters. So let me read this statement again. A closed rectangular box has to be constructed as follows. Dimensions: the length, the width and height. The length of the base have to be 3 times its width, right? The volume has to be 5 cubic meters. So you are told that a closed rectangular box has to be constructed, and it should have the dimensions of length, width and height. The length of the base of this box have to be 3 times the width of this box, and you're told that the volume of this box have to be 5 cubic meters. So let's continue. The material for the top and bottom costs 15 rand per square meter, right? And the material for the sides costs 6 rand per square meter. So I've tried to draw this box as shown here. So here is our rectangular box, something similar to this, right? So what are we told? We're told that it should have the dimensions length, width and height. So here's our length, width and here's our height. So if we're looking at a real box, this is our length here, this is our width and this is our height. So this side is here's our height here. So this length, this size here is our height. This is our length and that is our width. So you are told that the length of the base have to be 3 times the width. So the length of this base should be 3 times the width of the size of the width. So if this is 1 meter, this have to be 3 meters, because the size of our length should be 3 times that of the width. So if we're saying this is 2 meters, this have to be 6, because our length have to be 3 times the width. Our length have to be 3 times the width of this box. And then the volume has to be 5 cubic meters. So the volume of this box should be 5 cubic meters. That's what you're told. So let me write. So here's our length, here's our breadth, here's our height, right? So let's read question 1. Determine the width, show that the cost to construct the box can be calculated by this equation, right? So they're saying show that the cost to construct the box can be calculated by this equation. 90 this plus 48 with height. So they are just telling you that you must. They're asking you to show that the cost to construct this box can be calculated by that equation, right? So okay. So from the information that we have that the height, is equal to h, right? We have the width is w, and the length is 3 times the width, so it's 3w. So you were told that the size of the length of your box should be 3 times the width. So your length should be 3 times your width, right? So what we need to do, we're asked to show that the cost for the sides can be calculated using that equation, right? So now what you need, if you're constructing the box, that means you'll have the sides. It will be these sides that will be costing. So you must find the area, the total surface area of the box, the total surface area of all the sides of this box, right? Then once you have it, so once you have the total surface area of the box, you know that to build the top, the base and the top is 15 rand per square meter. Once you have the area of the top and the area of the bottom, you multiply it by the 15 rand, because each square meter of the area that you will have calculated will be costing 50 rand to build. Then you calculate the area of all other sides. Once you have that, the area of all other sides, also in square meters, then you'll be multiplying by 6 rand, because it costs 6 rand to build each side. It costs 6 rand to build each square meter. So you need to calculate the area of the top, the area of the base. Once you have it, you multiply it by 15 rand, because the area that you will have it will be in square meters, right? And then also the area of the sides, and then multiply it by 6 rand, because that's how much it will cost you to calculate to build the sides. That's how you do this. So how do we get this total surface area of ours? The total surface area, right? So I'll write it as T, total surface area. What is it? So you know, when you're calculating the area of a rectangle or a square, it's length times breadth, which is the width. It's length times breadth. So to calculate this size here, it's going to be the length times breadth, right? So if you're looking at this box, the box has similar sides to this. So this side is similar to this side is similar to this. Because if you're looking this box from the side, this is your view. But accept that it will be W here, at the base of the bottom it will be W, and at the side it will be H. So if you look at the back, you will have a similar view, except that this will be your height. If you're looking from the back of this box, this will be your height, and this guy here will be this, which is the same as the length, right? If you're looking from this side, you're looking from this side, not in front, from the side of the box. So what you will see have the similar view as this, but this, which is the same, what you will see when you're looking at this side is it will have the same dimension as this side. So you will see the height, which is the same as that, and this here will be your W. So you will have your height and your width. So if you're looking at the front, you see, if you look at the side, this is your view. You look at the length like this, and at the height there, which is that. So this is how you look at this box. Look at it side by side. So if you want to calculate the total surface area, you must calculate the area of all those sides, which is similar to this. Because here, if you want the area for this thing, you say it's length times breadth. So the area of this length times breadth. So if you want the area of this side, it will be the length times height for this front. For this side, it will be the width times height. For the back, similar thing. That's what we need to do. But now, you must be very strategic about how you go about this. So, start with the top and the bottom. Right? So I'm going to start with the base. With the base, where our base is the bottom of this box of ours. So if we're looking at this box, which is similar to this, if I want to calculate the area of the base, which is the underlying area, the base of the box, the bottom area, it will be the length of this box times the width of the box. So if you're looking from below, it's going to be this times that if you want to calculate the area of this of the base. It's the length times the breadth. So you will get the area of the base. So the bottom, it will be the length times the width. If you want to calculate the area of the base of the bottom of this. So it's going to be length times breadth. That will be the bottom. To calculate the top, it's similar dimensions. So here's the top. This is your length and this is still your breadth or your width. This is your length times the width, which is the same as this. If you look at it, it makes sense because this will be exactly equal to the top. This side is exactly equal to that. So if you're looking at this box of ours, so this is the bottom and the top should be exactly the same. So the top, which is this now, will also be the length times width. Length times width. So this is your area for the base, this is your area for the top. Now let's go to the sides. Right? So let's start with the face, this one here. So this is your length times this. What is this? This is the height of the box. So length times your height of the box. This is the front of the box. It's your length times the height. So the front of the box is your length times the height. Plus. So you have discovered that the face is going to be the length times the height. So you want the back. So if you look at it, this front will be the same as the back because they will be exactly equal. Let's say I turn this around so I can do the back. So let's now do the area of the back. This is the length and this is still the height. So that's why I said this side and the side will be equal. Because if you're looking at it, this is the length and this is the height. So plus length times height plus. So you have done the base, you have done the top. Okay, you have done the base, you have done the top, the first two. You have done the face, you have done the back. This one. So you're left with this side and this side. So what do we have on this side? This is the breadth and this is your height. So it's going to be the width times height. So it's going to be your width times the height. So if you're looking at here, this side is this side here. So it's the width times the height. It will be the same as this one on this side. Because here, this is equal to that and this is equal to that. So this side is also the width times the height. Plus width times height. So this is your total surface area. So if you want the surface area of this box, what is the area of all surfaces? This is how you do it. Right? So what do you do next? You can add the like terms. So these two is the base and top, these ones. So you can, so let's simplify this. We say, okay, we have 2 of length times W, right? There's 2 of these guys. there's two of these, 2 LH, this and that, and 2 of these, 2 WH. Right? Then you can substitute what you have and what you don't have. So TSA is equal to length times width. You are told that the length is 3 times the width. So we are going to have 2 in the place of length, 3 width, because you were told that, times W, plus 2L. What is your L? Is 2 times the width, 3 times the width, 3W, times H, plus 2WH. So keep in mind that this is the top and bottom, base and top, and these are the sides, right? So let's simplify first. So this simplifying the top, the base and top, because these two represent the top and bottom, because it was length times height, length times width, which is your base, which is the same as the top. That's why we have them there. So we have 6W squared plus, so this is the area of the top and bottom in square meters, plus this times this is 6WH plus that, so it's 8WH. So this is the total surface area. So we know to construct this part, this area, it will be 15 rand each square meter. And this one, it will be 6 rand each square meter. So now, if you know the area of the top and of the top and of the top of the box and the bottom, then we can multiply this area by 15 rand so that we can get how much will it take to construct the base and the top. So what are we going to do here? We're going to say, okay, the cost now will be equal to, we're told that to construct the base is 15 rand per square meter. So this is the base part, because these two that add up to this. So it's going to be 15 rand. It's going to be 15 rand times 6W squared. So this is the cost of the base and the top, plus 6 rand times 8WH. So 15 times this is 90. 15 times 6 is 90W squared, plus this time that, which is 48WH. So this is our cost of constructing our box. Here is it. So the most tricky part is calculating the total surface area. If you understand how to calculate the total surface area, you must add the area of all sides. But keep in mind, keep track of which ones are your base, because this was our base, this is our top, this is our L times H, L times H, it was our front, this one. And the other one is the back, and the other one is the top, and the other one is the bottom. So you know that once you get the area of the top and bottom, you multiply it by 15 rand, because this part, first part, is the area of the bottom and top. Once you have the area of the sides, you multiply it by 6 rand, because it's 6 rand per square meter. So you know that the unit square meter is 6 rand. So this is how you do this. Then you're done. Go to the next question. Okay, 9.2. Determine the width of the box such that the cost to build the box is minimal. Okay, so now let's go to 9.2. So we have proved this. I'm going to delete to wipe it from our board. So 9.2. Determine the width of the box such that the cost to build the box is minimal. So we want to minimize the cost of the box. So what width will give us that minimum cost? So we want to optimize the cost of building the box, so to a minimum. So what width will give us that? So that's what we want to find. So what we need to do is to express h, right, in terms of w as well. Once we have that, we to find our minimum width, we must derive this, right? So we're told that the volume is equal to 5, and we know the volume of the box. The volume, if you want to calculate the volume of a rectangular shaped thing, it's length times width times height. It's length times width times height. So it's going to be length times width times height. That is the formula for the volume. So let's substitute there. Our volume, we know it's 5 here. Our length, we're told that it is 3 times the width times w times h, right? So 5, this times this is 3w squared h divided by 3w divided by 3w squared. This and this goes away. Therefore, h is equal to 5 over 3w squared. So this is our height. So we've expressed our height in terms of w. So we know our L is equal to 3w, our w is w. Now we have that our height is 5 over 3w squared. That is our height. So let's substitute our height into that cost equation, so that all our cost now will be the function of w. It will be dependent on w. So I'm going to wipe this so that we have more space. Hopefully you understand this, because given that the volume is this, oh man. And you know the volume is length times width times height. Then on your V, put your 5, which you were given. Your L, you were given that it is 3 times. You were told that the length is 3 times the width. And your width, you assume is width. And your H assume is H. And then you solve for H. H is expressed in terms of W now. Once you have H in terms of W, you can substitute it back on the cost equation. So that's what I'm going to do now. So I'm going to write this as it is and substitute my H so that our height can also be expressed in terms of W. So cost as a function of W is equal to 90 W squared plus 48 W H. What is our H? Is 5 over 3W squared. That is our height. So the next step that we do, we derive from here, right? But we cannot derive if we have, so our rules of differentiation don't allow us to derive if we have our variable as the denominator. So we must take it up, that W. It's not going to be there. So to do this, we say, okay, our cost as a function of W is equal to 90 W squared plus, okay, so we can simplify first, and then left with 1 there, so we have 5, we have 48 into 5 over 3W. This is what we have now. So this W is cancelled by that product of W's at the bottom. So we're left with 1 there, which is this. Okay, so simplify this. Okay, simplify this part. So this is equal to 90 W squared plus 5 times 48 over 3. You can punch it on a calculator. We have 80 here over W. So we can punch this 48 times 5 over 3. Get you 80, right? And then now, you want to move this W out of here to the top. So the cost of W, or cost as a function of W, is equal to 90 W squared plus 80 W raised negative 1. Then now you can derive. C prime W is equal to, this times this is 180 W. So you are deriving 2 times 90 is 180, then subtract 1 with this. Plus negative 1 times 80 is negative 80 W minus 1, so it's going to be minus 2 here. So cos prime as a function of W is equal to 180 W minus 80 over W squared, right? Then you equate this to 0 to find your minimum. So 0 is equal to 180 minus 80 over W squared. Oh, so 180 W over W squared. So you're solving for W now. So multiply it throughout by W. What do you, by W squared? What do we have? We have 0 is equal to 180. 0 times W squared, 0. 180 W times this, 180 W cubed, minus 80. Right? So what do we do? Transpose 80 to this to the right. Negative 8 to the right becomes positive. So 80 is equal to 180 W cubed. Right? What do we do? And then now, so from here, I'm going to wipe this because I assume that you are following up to that very point. Because we want to find the minimum width. So what do we do? So we say, okay, we divide by 180, so we have W cubed is equal to 80 over 180. Then we take the cube root of this, cube root of that, so W is equal to the cube root of 80 over 180. Punch that in the calculator, cube root of 80 over 180. So W is 0.76 meters.